Okay.
All right, so I'll look at it from a chemistry perspective. To give you a little bit of a perspective is actually, no, that's not my point of view of struggling, but that is the point of view of a lot of my students struggling with chemistry. We teach a 900-person general chemistry course with 3 sections, so we're still seeing about 300 students at once in those sections. And we do, if you ask our students, the first half of our class is extremely math heavy. But what I was noticing is students were struggling to apply conceptual understanding to what they viewed as a math-based problem. So you can go ahead, Tara. And so to them, if they were able to use an equation to solve it, if there was an equation, if there were numbers to plug in, students were just viewing it as a math problem, where their calculator gave them a number and that was the answer and then moved on, instead of really interrogating both before and after. So before they even used the equation or the numbers, thinking about, what am I expecting to see? What does this mean about the system that I'm exploring? A good example would be, we will tell them they're calculating the final temperature of a hot pack. So we're literally telling them the temperature will go up, and the number of answers we get with a lower temperature, and they're like, but that's what the number said. And really, this idea that that number in chemistry and even the sign, whether or not it's positive or negative, has a conceptual meaning to it. And that's where kind of that disconnect was happening. They were coming in, they were using the numbers, saying they got an answer and moving on. So, next slide. So in my interview, I was looking, this is kind of how students see math-based problems. Like, you're driving down a road in your canoe, your tire falls off, how to get the pancake. Like, they have no connection between the different parts. It's just a problem and they're moving to the next problem. And then we're reading their answers, and our first thing is that that doesn't even make sense. And so students would ask us if they were correct, and I wouldn't even have to look at their work. I could just be like, no, your units don't work. And they would just look at us like we were this amazing, how did you know that? And so looking for us, we make a prediction first. We look at the information in the problem along with our prior knowledge, and we make predictions about what we expect in our calculations. And those predictions can be magnitude, sign. Those are usually 2 of the biggest that we look at. And then we calculate our answer, right? And so for us, what I want to do with that answer, not just the number, but I'm going to link it if I'm talking about, I'm going to say jargon for a minute, but heat transfer. If I'm talking about heat transfer, I'm going to link that to my existing knowledge. And the big thing for our students is helping them understand that the knowledge, non-chemistry that they come in with, they've been injured, they've used an ice pack, or they've been cold and skiing and used a hot pack, things like that. That existing knowledge can actually help them in context in science. So helping them, we as scientists use not only our chemistry knowledge, but also just our day-to-day life and ask, do our answers make sense? And then we actually take the minute to go check whether our answer agrees with our prediction. And if not, where is that difference coming from? So those are kind of the 3 steps that a very frustrating interview eventually got to. Because I think, as Tara pointed out, I forgot that I do that prediction because I just naturally do it when I look at my calculation. All right, if you look at the next one. So how do we help our students develop these habits? So the first thing we did was give them an approach. So we call it our pack method, and our canvas was decorated with Pac-Men because we like them. But it gave them something to remember. We printed this out on an obnoxiously colored neon sheet and gave every student their own. And it was just predict, answer, check. And so getting them to think about it, and we referred to it, we would put it on our slides if we were giving examples in class. And it just helps them understand not only what steps an expert will take, but what is within those steps. So when we look at the answer, what are you solving for? What are you given? What equations do you need? So even breaking those steps down a little further for them and providing that. And then we also, as far as helping them practice that, once we gave them that framework, so we built in the thought process in our formative assignment. So an example is the one on the left. So before we had them work to determine the answer, we would ask them to predict the sign and why. So instead of just like, oh, I think it's going to be positive, but where are you drawing that from? And then the magnitude, should it be larger or smaller in this case than the particular number they started with? And again, why? So forcing them to do those steps before they got to the answer or the working for the answer. And then we also, when you get desperate, we just got rid of their ability to rely on the math. So we just took out the numbers. And so they could still use the equation in a qualitative sense, but they couldn't jump to just calculating a number and moving on. because we just didn't provide that option. So they were really, that helped them focus on the first two parts of that predicting. And so, sorry, I didn't do an impact, but I didn't do a separate slide, but we saw a lot of the same things Megan did. Our questions are better. Instead of students just showing me a blank page and going, I don't know how to do this, or am I right? I get a lot more students going, I don't know where I went wrong, but I know it can't be right because I know activation energy has to be positive. And so they're showing a connection where they're thinking about their answer and not just getting a number and moving on. And that's made a huge difference, not just obviously in their outcomes on their grades, but also in the way they approach challenging things. When we give them more challenging questions, they're able to pinpoint, they will get started and then pinpoint where they're going wrong. And for us, that's going to be something really valuable as they move on in chemistry.